Let's start off this session with probability. And we're going to go through some of the different forms of probability we have encountered. As I start off by importing the necessary libraries, you can still read up more about them. So with classical probability is that there is an assumption that all outcomes are equal. So for instance, when you're rolling a dice, the outcome of a 1 or a 2, it's still going to be 1 out of 6. The outcome of tossing a coin is still going to be a half on either end of the face, okay? Now, if we look at our particular example, like for instance, we want to know what is the probability of rolling a dice, and we want to do this in Python. And we want to know specifically the probability of getting the 4 when rolling the dice, okay? This can be generated as we already know the number of events for rolling a 4 is 1, okay? And we already know the total number of events is a 6. So we can simply write this as a formula of 1 out of 6, but we want to output it into a variable. We want to output our result into a variable. Okay, so we can call it maybe the probability of 4. So what I'm calling my variable is equal to 1 divided by 6. Okay, and if I want to view this result, I would then call out the variable p over 4 and execute that. However, if I want to write results as a function, I would then write print, okay, brackets, then write a sentence of how I would want this result to be presented, okay? And this sentence must be in quotation marks. I then say the probability of rolling the 4 is, okay, that's my sentence. I then use a colon, space, then a comma, and then I call up the variable to which my result is outputted, which is p underscore 4. Okay, so that generates for me the result. And there are different other ways in which you can write your functions, but that is all up to you. There's plenty out there that you can try out. Let's look at another type of probability. Let's look at empirical probability. And here, this is based on experimental data, okay, or observed data, okay? And you're asking this observed data for a particular piece of information, okay? From that experiment, you want to know what is my result? What is the likelihood of a particular event occurring? For instance, let's look at our loans data set. And we are particularly interested in looking at what is the probability of, say, one going through a property area that is semi-urban or urban, okay? So looking at the loans data, what is the probability of, for instance, the property area, the individuals in there. Okay, so I'll still go ahead and import that data set. I'm going to call it a data frame data. Use pandas to read it in. Brackets, quotation marks, and call up that data frame or that data set, which now is outputted as a pandas data frame. But now I'm interested in just the probability of a specific variable, okay? So I can call up that probability and I'm going to output it to a variable that I'm going to call maybe probability 1, okay? And I say in that, I would like within that data frame, specifically the variable property area, which comes in our dropdown. And I want to look at the values within that particular variable. So you count the values, and then I'm going to divide it by the total number, okay, or the sample number, which is the length of the entire data frame. Okay. So I can then write a function to help me view that result. So I would call my function print in quotation marks probability of property area is colon space, and then I can enter the variable that I had generated, which is called probability 1. Okay, hold on. I should now see what my result is giving me as the error, okay? So it is letting me know that unsupported slash mark in the method and the integer, okay? So then it is letting me know here that the manner in which I have written it has found issue, okay? And that's because I forgot at the value counts, and it is letting me know right there that I forgot to put the brackets, okay? So we should look at our errors and what they are telling us so that we can be able to troubleshoot for them, okay? So there I can see now my probabilities for these 3 categories, okay? Now they are put as decimals and we know we can have them as percentages, okay? So what of the conditional probability, okay? This is now with conditions. Like we had one of the assignments being a situation of a conditional probability. Remembering that the formula here for the probability would be, or for the conditional probability would be probability of one event, okay? Given that the other event has already occurred. Let's say the first event is B, and we want to know what is the probability of A given that B has already occurred. This would be calculated as a probability of A intersection B, okay, divided by the probability of B, the original event. So if we had to go into our data set, and let's say we want to look at what is the probability that a person in a semi-urban area gets a loan status of N, okay? So we now know that the N is the starting variable or the starting condition or event of B. So our B in this case is the loan status. And we are specifically interested in the loan status of N. And the A in this situation is the property area. And we are only interested in the individuals from a semi-urban area, okay? So we would have to impute that very formula to be able to calculate the conditional probability. So we would do this by first generating the outcomes of each of those events. So if we want to look at outcome of semi-urban, okay, we would generate here a variable, let's call it event semi-urban, and we're going to use it to calculate how many outcomes we see that are semi-urban, okay? In our data frame, pulling it up, and then we specifically are interested in the property area, but more importantly, and this is why we use that double equal sign, because it says to exact, okay, to that particular wording or that particular number. We put that word into quotation marks, be certain to spell it exactly as it was, and use the proper casing, okay? So we can get that result, okay? We can look at it. So and generate that result. I could pull it up as just the very result, okay? So here it has just subselected only those pieces of information that only have semi-urban dwellers. And you can see there are 233 rows, okay? So we can do the same even for the ends on the loan status, okay? And I'm just going to use exactly this code so that I don't have to write along something. And I'm only interested in event M, so I'm just changing these specific areas. And I'm interested in the loan status, okay? And specifically looking at N, right? So this is just a way to subset the data to get only those events that you're interested in before you can calculate the conditional probability. Once we are done with that, okay, we can go ahead and look at the outcomes, okay, of having both events, okay, which would be the joint probability. The outcomes or likelihood outcomes. All right, so in this scenario, we can generate a variable that we call perhaps our joint events. And to it, we are looking at our data frame in the parentheses and specifically looking at property area, right? Just that. I'd forgotten to add the data frame. Okay, I'm specifically looking at semi-urban. Okay, so the double equals to sign, the quotation, and making sure to spell semi-urban correctly. And then close that bracket. And then we can use the and sign. Okay, so this is a way to pipe our codes together. And we're saying we're also looking at the other event. Loan status. I could put that in the quotation marks. And we are specifically looking at N. So I can already see there is an error coming up here in the manner in which I have written the code. So I have to look at this and make certain that it is properly written. I can see from this red quotation that comes at the bottom of the code. So I have to go through it again, okay? So it's meant to be the data, parentheses, data, property area, semi-urban, and let's just give that a whirl. Okay, so incomplete input. All right, so it's incomplete because I have my N not in quotation marks. Just recheck that. Events, semi-urban, data. All right, I have an incomplete on the parentheses at the end. I had just the one over here and I didn't have the second one over there. Okay, so that would generate for the joint events, okay? So then we can calculate the probability or the conditional probability of these two events. And we would do that by getting we're going to call it a variable conditional, one perhaps. And then from it, we will generate the length of the joint events divided by the length of the data frame, right? So let's go ahead and view that result. I'm not writing it as a function in this instance, so I could write it as a function. It depends on oneself, okay? So I'm just going to call it up as the variable itself, conditional one, and get to see that result. Okay. String, so I do have another error that I've generated in here. Okay, I just have to look it over and make sure that I have written this correctly. Additional one. What is my error saying? String and integer. Okay, it's again with my brackets and joint events. Okay, so my brackets were meant to be over here, and rather than being right at the end, okay? So then that generates for me that result, which is a very small probability for having that kind of scenario. Okay. So once we have the conditional probability, or the rather the once we have the events and we know the outcomes for each of them, then you can generate your conditional probabilities. It's just a matter of remembering how the formula is generated rather than doing it from scratch. If you start with the formula and you input your variables into the A and B formulae, then you can be able to generate it. Okay, so this would be then the joint probability, okay, of those two events. Okay. Joint. Okay, I'll just change this, and it's the joint probability of these variables. Okay, and we can see what that one looks like. And that is what we got. But if we want to then see the conditional, we need both the joint and it being divided by the probability of the B, or the B element, which was the event that started before, okay, which was the launch status of N. Okay, so this we can do by computing the, we'll call it conditional probability, dividing the joint probability with the probability of the N events, which we had as we have the events for N, but we don't have the probability for N. So we need to generate the N probability, okay? So let's generate the probability for N, or launch status N, and that would be, we call it probability N is equal to the length of event N divided by the length of the entire data frame. Okay, so we now need that probability to compute our conditional probability. So let's view that result, which is conditional probability. We can execute that and we get a value of 28%. Okay, so just keep in mind, because it can be a bit long to enumerate, just keep in mind about all the aspects, all the parameters that you need to stick with. Okay, so now we'll go into the marginal probability. Which is one we have had some experience with. And here you're looking at an event occurring without thinking about the other events. So these would refer to mutually exclusive events, okay? So you would see this as a sort of unconditional probability. So it's the opposite of what we have with a conditional probability. And it has no ties, so you have mutually exclusive events. Okay. So just because one happens, it shouldn't affect the others. It will still happen. Its likelihood of occurring will still go on, okay? If we want to look at the marginal probability, the approach we use when we are enumerating it for a categorical variable versus a continuous variable have some differences, okay? So if we are looking at a categorical variable, such as the property area, okay? And we just want to know what is probability of an urban dweller, okay? Someone who has the category urban under that property area. Okay? So it would be like a classical probability, okay? So if we call it the variable urban, prob urban, we'd still look at the length, okay, of our data frame, or the length of our property area specifically. Okay, property area specifically, looking at only the category urban. And then we would divide that by the length of the entire data frame, which is pretty much a classical type of probability, okay? But if we are looking at a continuous variable, remember continuous variables tend to have a lot of numbers to them because they are measured, okay? They are measured variables. So they have an infinite set of entries or infinite set of numbers. They are quantitative, okay? If, for instance, we're interested in the marginal probability of a variable loan amount, the first thing we realized, it was easier to carry out the probability for the categorical because it has these categories. It limits us on what you are looking at. But in this scenario, we have no limitation. We have a range of wide numbers, and to carry out the probability of each one will be a difficult aspect to be calculated. So what we tend to do is we turn the entries for that variable into discrete bins or discrete ranges, okay? So that's discretizing it. So the way in which we have been doing it is, for instance, if you have a small data set like we have in our instance, in this example, you can see where your maximum and minimum are, and then sort of go and generate these bins and labels manually yourself. Let's, for instance, generate a variable called bins, and we are specifically just going to write in the bins, the number of bins that we would like to have out there. Okay. Say, for instance, I want to have, if I want to limit it down, and I want to say, I am going to limit it down to say, 7 bins, okay? I could start with the first one that is going to capture all the data until 9. The next one is capturing it to 100.0, as these being the loan amounts. The next capturing it to 200. The next capturing it to 300, 400, 500, 600, 700, okay? But I have to explain what lies within those bins, which values lie within those bins. So I generate what are labels, okay? You can call them anything, okay? I just call them labels, but it's simply to explain what goes within these particular bins. Bins being the stock points, okay? The ranges that you are generating. So here I would put them in the quotation marks and explain that if I'm talking about from 9, what am I talking about? I'm talking about 9 to 100, a value of that etc. Then in the next bit, I'm talking about values of 100 to 200. In the next bit, I'm talking about values of 200 to 300, all the way till I can get to 700. 100 to 500. 500 to 600. 600 to 700. Okay. And so here I've generated those bins and labels. Now, they haven't yet been used to transform the data set itself. The data set still has its loan amount, the same way it has been the entire time. So we need to apply it. Okay, we need to apply these bins and labels to the data set and transform it. Okay. So we use a function called cut that exists in pandas. And what cut does, it's going to apply this transformation to the data frame, okay? So we'll call up our data frame, and we are specifically looking at the bins, okay? When we're generating a new variable or a new column that is going to contain these bins, let's call it loan amount bin, okay? So this will be a new column within that data frame. And we're using pandas cut function. And we are transforming our data frame, but specifically looking at the loan amount. And then we can describe for it what the bins are, okay? We have our bins as these that we had generated. And we need to explain to it which are the labels. Okay, we already have our labels being called labels. Is over here. And so we can use the right to segment that data, okay? Okay, so this will transform or discreditize that data frame before you can go ahead to calculate your particular marginal probability. Another way we can discreditize, which is much more efficient, especially in situations where we have a very, very big data set, because in this scenario, we can see we were doing it manually to add our labels and our bins, which takes very long, okay? We can just use the Python cell. We can use something called the equal frequency binning. So this will generate bins, okay, based on the number of observations. So it will try to bin the data by having an equal or same portion of observations or samples within it, okay? And it cannot work with variables that have missing data. So you have to first transform or pre-process your data set before you can use this kind of binning or discretizing your data or your continuous variable. So we use the library feature engine rather, because it has the function that allows us to do the equal frequency binning, and it generates these frequencies that are made equally, okay? So to do that, we can first import the libraries for it. If it's the first time you're importing it, do make sure to first install it. Remember, the code is to write your pip install, okay? But in this instance, I already have it installed, so I will not be doing that. So I would import the feature engine. And from the feature engine, there is a feature engine for discretization, okay? So I'm going to also go ahead and import it from feature engine, import the feature engine dot discretization, okay? And within that discretization, I want this particular method of the equal frequency binning. So I say from feature engine dot discretization, import the equal frequency discretizer. So it has even the equal width discretizer and equal frequency or equal width, okay? So I execute that and I go on to see how I can do that binning, okay? So to do the binning, you have to decide how many bins you want to generate. In our instance over here, we had made 7 of them, okay? I want to, for instance, make 10, okay? And to generate those bins, they're usually within the function, they are called queues, okay? Those number of bins. So we'll see as we write it. So I'm going to call my discretizer any name. Maybe I'll give it discrete. And then I will use the library and inform it how many bins I would like. I want 10 of them. And I form it which variables I would like to have discretized, okay? I specifically want loan amount, discretized, okay? But it hasn't yet done it, okay? So I go ahead and I create a copy of my data frame. By creating a copy, I'm leaving behind my original data frame without transforming it, and I'm only going to do the transformation on the copy, okay? Otherwise, I would have to generate a second data frame to which I'm doing this transformation, okay? So I call this data copy is equal to data copy, data.copy quotations, okay? So now I fit my discretizer onto the copy on the copied data frame. Okay, so my discretizer is called discrete. And I say I want to have it fitted, okay, onto a copy data frame. And in the end, I can even generate the dictionary, the Bina dictionary for this particular discretization, okay? So the Bina dictionary would be the similar way that we have the labels, okay? For those bins, right? Once I have that, I can now use it to transform the data set or to do the binning, okay? Or transform. And I'm specifically doing it on the copy. I call up my data copy, equal to, I use the discretizer dot, I then transform the copy data frame. Okay. If I want to view these results, perhaps I want to view them in a visual manner or in any other way to see what is the difference in terms of the non-binned data frame and the binned data frame, okay? I can maybe define for myself a function that I'm going to call plot. And in this function, I am stating the variables at hand. The first is the data frame that is the original. The second is the copy data frame. And then I'm specifying the variable that I'm working with, which is loan amount, colon. I continue defining other parameters within this plot function. I let it know that I wanted to plot a figure, and I give the size specifications like we've been doing. And this, I am just giving some generics. People do change the sizes based on how much data you have. Okay, you can play around with that. I am then using Seaborn as my library to do the plotting. And I want to generate a count plot specifically, okay, to see this variable. And on the x-axis, I'm then saying, call up the data frame x, okay? And it should have the variable in it, okay? So I've not yet started using the function. I'm still describing other aspects of this function, like getting a title for my plot. So maybe in one instance, the first plot can say before binning. Okay. And then also continuing to say that the plot should be displayed. Okay. But now I've only done this for X. Okay. The data frame that is the original. I need to continue defining this function, which I will do exactly the same thing. Plot figure. Okay. And the figure sizes, I'll just copy paste these. And what I'm asking Seaborn to plot, I'll also copy paste this, but this specific to change, that is not X, I want a copy data frame, okay? I then also copy paste what the plot title should be, but this plot title is going to say after binning, and then I can complete my defined function with the plot show. All right. So now that function is complete. Okay. Now I want to use the function to generate visuals. Okay. So notice every time you have that spacing, you'll either get an error code or it's expecting that you're still in the middle of writing a function. Okay. So I want to use the my function, which I called plot. I then say plot, okay? And I'm now going to define the X and the X copy and the variable. You see, this is what it's asking me. X, any, what is the X copy and what is the variable, right? So my X is data. My X copy is data copy. My variable is loan amount. Okay, so I need to then execute this and see what happens. Okay, so again, I have an error here with the particular brackets or such. So I'm just going to put this in another cell so that I can easily be able to see where my error is. And this is why it's not advisable to write all of your codes together in one cell, but rather write them all together once you know that they have no errors within them. Okay, so my error started ages ago. Okay, check and remove this before using this transformer. Okay, so I should check and see what error I have caused there with my quotation marks. Right. Data copy. Request discreditizer Q10 variables. Just first also remove these from this cell and see if I had any other further error. Okay. Right, let's check here. Hit to the copy. All right, so this is where my error is at. Call this transformer. Okay, so right, data copy, data copy. Okay, discredit fit to the data copy. And bin a disk. Okay, still looking. So already I can see where my error is at. It lets me know that some of my data contains NaN or missing data. So this is why it has specifically gone and called it up as an error, because in this particular variable, I have missing information. So we'll just change it to another variable for now. Let's look at applicant income. Okay. And let's see. Okay, so in this instance, it works. So that was our error over there. So I should make sure to change this as well. In terms of the variable, and then I can have a look, say. Okay, so we can see here that before the binning is this whole long range. And then after the binning, it's this kind of scenario. But we can also change this if you'd like to a histoplot so that you can get to see it in a different way, okay? So these are the different types. There are very many other different ways in which you can discreditize, but you must be sure about the method and what shortcomings it might have. In this instance, we've noticed it has the shortcoming of not being able to deal with variables that have missing information, okay? So going back to that marginal probability, so if we go back to the marginal probability itself, remembering that we had used, for instance, this method over here, okay? The marginal probability would then be, okay, the loan amount bin, or that new binned variable that you have generated, and its counts divided by the actual length of the entire data frame, and then you can generate those results, okay? So we can stop here for now, and we'll get back in another session.